All right. The first day of our notes for Chapter 6, Lesson 3 was exponential growth. I talked about things that were increasing. Money was increasing. Population was increasing. Things were doubling, tripling, getting bigger. Today we're talking about decay. Decay means that I'm making something smaller. I'm getting lower, less. Things could be decreasing at a fast rate. So, the graph of exponential decay, definition first, looks like this. It goes downward. And then the formula is still the same. F of x or y equals, either one can be used, a times b to the x, but b is going to be a number less than 0. Less than 1. So here's some decay, like y equals 50 times 1/3 to the x. Or f of x equals 200 times 0.7 to the x. So these numbers that are in parentheses, my b value is going to be a number less than 1. I could represent it as a fraction, or I could represent it as a decimal. All right. My formula for doing math, like, with my formula like this one is P1 minus R to the T power. Please, guys. The principal multiplied by 1, take away the interest rate. So we're subtracting the interest rate. We're not adding. So this is the difference. I've got growth and then decay. Growth and decay. Plus sign, minus sign. All right. So now we're going to go to the examples, which are starting, I think, at example 3. Example 3. All right, example 3. My formula is P1 minus R to the x power. This is decay. Example 3. A video is labeled a fan favorite if it receives at least 1,000 views per day. Amelia posts a video that gets 8,192 views on the first day. So there's my y-intercept. 8,192 views this first day here. The number of views decreases by 25%. Okay. How many days will the video stop being a fan favorite? And my main question is in 8 days. So I'm really asking, not in how many days, I'm saying in 8 days. My principle is the views. How many people watched the video on the very beginning? 8,000. Yep. What was the rate that it decayed? 25%. Please write it as a decimal, 0.25. And how long time am I wondering? 8 days. Just 8. 8 days what? I want to know what the views are after 8 days because it goes down every day. Here's my formula. F of x or y equals. Now, P parentheses 8,192 parentheses 1 minus R 1 minus 0.25 raised to the power of 8. So that's what you're plugging into your calculator. Everybody's got the same one as me. If you're at home using your own calculator or your cell phone, you need to do the 1.25 or 1 minus 1.25 to the 8th power first. So I could do that actually first. 1 minus 0.25. 0.75. This is what you would have to do if you didn't have my fancy schmancy calculator like I have here. So basically on your homework. Then I would do 0.75 to the 8th power. .75 to the 8th power.
How you do it?
How do I do it? I'm typing it in.
I know, but when I pressed it, it didn't work when I did the power.
Oh, I couldn't tell you right now. Sorry.
This is V.
So I have to multiply 8192 times 0.1. You want to write as many numbers as you can, but remember, this is if I'm at home. Times 8192. 820.
Wait, is that?
Wait, I just did
All right. I just modeled for you how you would do it at home if you didn't have a nice calculator like this. Now I'm going to model for you in class using this calculator. 8192 times 1 minus 0.25 raised to the power of 8. So this is what your calculator in class would look like. There's too much talking, guys.
Oh, wait, I got that.
So this is the in-class calculator method. And I would still get 820 views.
That was so fast. That was faster.
But you won't have my calculator at home tonight.
I know.
So, all right. We're done with that one. In 8 days, the views are only going to be 820, which means that's not a fan favorite anymore. Because remember, 1,000 views is like fan favorite according to this math problem. Example 4. The number of pica, which is this little like rodent, I don't know where they live, in a region is decreasing. After 3 years, how many pica will there be? So I'm looking at the picture. It tells me some info that I need. The initial population is 144 picas. The pica population is decreasing by 8% a year. So this is a decay problem because it says decreasing. P is what I start with. Rate is what I'm decreasing by. T is my time. What is my P? What did I start at?
144.
144 little mice things.
Wait, what does P stand for again?
Principal, how much we started with. What did the population start at? Or the amount of money I had to start. Or what's my rate of decrease?
8%.
8% as a decimal though. Yep. 0.08. How long do I want to know? 3 years. So, starting at 144, 1 minus 0.08 raised to the third. Okay. Do the math. You got to be able to do this without my help. So,
Thanks for the future. What the William?
all right. How much did you get? 0.12?
Yeah.
112. So 144, 1 minus 0.08, close the parentheses, raised to the third power. Is that what your calculator said? Those of you that said you didn't get it. 112 picas.
What is your? I got a question.
Quickly, go ahead.
So like, if we take a quiz, we're allowed to calculate.
Yes, in class. Yep.
Yes, sir. We're taking a quiz tomorrow, right?
No.
Oh.
All right. Turn the page.
Oh.
Okay. I want you to write down this problem down at the bottom of the paper, wherever you have space, starting in 1920. Starting in 1920. You're writing it down on your paper.
Why? We all understand this very well.
Starting in 1920, Bodie ghost town's population decreased. It halved. It's a ghost town in the desert, in the mountains. It halved every decade, so it just decreased by a half every decade. In 1920, 80,000 people lived there.
So that's a start, right?
What was the population in 1950?
There's 2%. I am not.
This one does not have a percentage.
Oh, half. I underlined it.
So what do you do for this?
I know, we're going to talk about what we do. So my rate of decay, it's decaying by a half. The population cuts in half every decade.
So it's 50.
Well, I just want to make sure you guys have it written down.
150? Oh, we gotta talk about that.
Oh my god.
Oh, you stick with the arm.
So, what did the population of the town start at?
80,000.
80,000. Great. Now, so I put that down. Let's talk now about the rate. I'm not going to do a 1 minus. This is like the problems that we had in homework where it doubled or tripled. I'm going to use a half or 0.5. It's kind of whatever you prefer. But I do know that my time is 3 decades. 1920 to 1950, 3 decades.
Oh,
1920 to 1950, 3 decades.
you don't know 20?
No. In 1950, you guys have to count yourself. From 1920 to 1950, how many decades is that? Yeah, 3. So, formula. I am not going to do a subtraction for this problem. I did not get an interest rate or a rate percentage. So, this is all you're going to put in.
Check it out. Okay. Wait, we don't put the 1?
No.
Why?
Because I didn't give you a percentage rate. I just told you it halved. Cut in half. Half. Half.
I have the answer.
Good.
Hold on.
I'm ready to hear it.
10,000.
10,000 is correct. 10,000 people lived there in 1950.
Will we get marked points off if we don't put people live there?
Yeah, because you're not answering a complete sentence.
Oh, gosh darn it, guys.
Answers in complete sentence. So, if I'm not giving a percentage, it halved or something like that, I just look at it. If it says doubled, which is growth, I'm going to put a 2 because doubled is 2. If it triples, that's growth, I'm going to put a 3. Anything less than 1 is a decay. Anything greater than 1 is a growth. All right. Last one. Now that we for sure have time, we can do the car problem. I am not going to worry about maintenance cost. All I'm asking you is the car decreasing. When you buy a brand new car, you buy it, you drive it off the car lot, you keep it for a week or whatever, and the car instantly is worth less money. So it's called depreciation. The value of the car isn't the same because it now has lots of miles on it. You drove it. So you're going to experience that when you have a car for many years, it will be worth less money. So what's going to happen is I'm going to have this car. Rich is comparing the cost of maintaining with depreciation. We're just worried about depreciation. The value. This car that he bought starts at 20 grand and it decreases by 15% each year. This is my formula, 1 minus R to the T, because I have a percentage, 15%. My P is what the car was bought, $20,000. My rate is 15%, 0.15. My time is here. Let's calculate depreciation after 5 years. Yeah, question? Yep.
For the percent, are you always just going to move it to the right?
2 to the left is the method. Yep. Russell, stay with me.
What was that?
So set it up yourself without my help. Use this formula right here. Share the answer with a neighbor when you get it.
8,874. 8,000. I get it now, Mister. Wait, let's try it.
All right.
Can we try it without your calculator?
So, how much money is the car worth in 5 years? Woo! 8,000 is a big decrease, you guys. 8,000 what? Huh?
And 1 penny.
And a penny. We can forget about the penny. No one's going to give you an extra penny for the car. So, the car was 20 grand and now it's only 8,000. That's a big decrease. You lost a lot of money on your car. Okay? So, Decay means the number next to the exponent is less than 1. Growth means the number with the exponent, the base, is bigger than 1. Adding versus subtracting. Okay? So, I'll stop the video and we'll talk about the homework paper.